Let's take a look at this exercise here. This is by far the most difficult one in this booklet. And the first thing we should do is to find the derivative of this. There's a lot of differentiation here just to make you get some repetition of this. And in the first exercise there, we have this function f of x is equals to ln to 5x divided by k times x. And we should then find the derivative, and we have to use the fraction rule. I would call it quotient rule here, right? And remember, the quotient rule for differentiation is u derivative times v divided by u minus the derivative of v divided by v to the power of 2. And what do we get then? F derivative of x here. We first have to differentiate ln to 5 over x, and I will do that over here, right? If we find the derivative of this, we could draw a bracket here, it's easy to see. Then we have to use the chain rule. So when we find the derivative of this, we think ln of u is 1 over u. Right? Ln to x is 1 over x. Ln to this is 1 over this. But since it's the chain rule, we have to multiply with the derivative of the core, and the derivative of the core is 5. And then I shorten this, so I get 1 over x. So the derivative of u is 1 over x. That's u derivative. And then times v, which is k times x, minus u, which is ln to 5 times x, times v, derivative of v. And if a derivative k times x, I will get k, right? If I find the derivative of 8x, it's 8. Of 5x is 5. So the derivative of kx is k. Divided by kx square. And let's see if we can make this a bit easier. Here we can actually shorten x against x. So I just get k here minus, and I just write k first, and then ln to 5x. And here I should multiply this by itself, so we get k squared times x squared. And we're getting closer to what the answer should be here. And we see that we can factorize the denominator here. Here we have k in common. We have two terms, k is in common. Put k outside the bracket here. Then we have nothing left there. So it's 1 minus ln to 5x divided by k squared times x squared. And then we can reduce factor against factor. So we can take k here and reduce it to one of these k's here. So I get 1 minus ln to 5x divided by, there's only one k left now, kx squared, which was exactly what we wanted to get here, like this. So that was exercise A. And then exercise B, it says the graph of f is exactly one maximum point P. Find the coordinate of P, right? And if we want to find maximum or minimum points, we always take the derivative equals to 0. So we have to find out when this is 0. So put this equals to 0. And remember, if a fraction is equals to 0, then a denominator, as we talked a lot about, has to be 0. So I have to solve this equation here. This is an equation with ln. So I get ln by on the right hand side here. And then to get rid of ln, as you may say, we take e to the power 2 on each side, like this. And the thing is then, remember, e to the power of ln p is equals to p. That's the definition of ln to a number. So e to the power of ln 5x is 5x. So I get 5x is equals to e. And then I just divide by 5 on each side. And I get x on this side. And I get e divided by 5 on this side. Yes. There we go. So that is the x coordinate of this maximum point. So this maximum point, which is called P, this point here, have x coordinate e over 5. But then I also have to find the y coordinate of this point here. And to find the y coordinate of any point on any graph in the whole world, I put the x coordinate into the function. And what was the function? The function was this, right? That was the function. So I just put e over 5 into this function here. So I get ln to 5 times x, which is e over 5. I really prefer to have a bracket here. Divided by k times e over 5. So I put in x coordinate here, and then you can see that you get 5 can reduce here, so you get just ln to e divided by, this can be written in different ways, but just write it like that here first, like this. And then we have to remember that ln to e is actually the number 1, and I may write like this. Okay, just multiply x k up here, and then we have a complex fraction. We don't like complex fractions, so I just multiply by 5 up and down here. So I get 5 divided by k times e. So that is the y coordinate here, 5 divided by k times e. So then we have the answer on exercise B here. And then we have the second derivative, and I think I will quit here and make a new video with C and D. So just so I end this video and make a new video with C and D.